Welcome. We'd like to take a look at a quadratic equation that again we will find to have complex number solutions. It's just an additional example to help us feel comfortable. If I want to solve this quadratic equation, we're going to use the very faithful method of completing the square. So I'm going to write this as x squared minus, now I could write it as 6x, but I'd like to observe my b value right away. So I'm going to write this as 2 times 3 times x, and I'm going to add something to complete the square, and this is equal to that -10, plus I have to add something to complete that square, right? I complete the square on the left-hand side, whatever I add there, I need to add over here. This gives me a b value of 3, and I need to add 3 squared. Now, you might be wondering why I'm calling it b, and that's just because in my mind, I have it solidified that I'm trying to write the form x minus b squared. Sometimes it's x plus b squared, sometimes it's x minus b. The plus or minus is determined by whatever the coefficient here is. So if I want x minus b squared, this is x squared minus 2bx plus b squared. So adding the b squared is what completes the square for us. I just have to identify what that b value is. So I'm going to observe that 6x can be written as 2 times 3. 2 times b. 2 times 3. That identifies the b value of 3 for us. Excellent. The left-hand side, therefore, is x minus 3 squared is equal to -10 plus 9 is a -1. So I'm going to have square root of both sides gives us x minus 3. The absolute value of x minus 3 is equal to the square root of -1, which we just learned recently is I. I can go ahead and add 3 to, well, I can't add 3 to both sides yet. I have to separate this into the two linear equations. X minus 3 is equal to I, or x minus 3 is equal to -I. Now I can go ahead and add 3 to both sides of the equation to find x is equal to 3 plus I, or x is equal to 3 minus I. And those are the solutions to our quadratic equation.